Something changed. On October 29, 2025, as the interstellar visitor known as 3E Atlas reached its closest point to our Sun, it did something unexpected, something that has left astronomers scrambling for explanations. And what they're discovering now is making some scientists ask questions they never thought they'd have to ask. This isn't about another comet passing through our solar system. This is about an object that traveled for billions of years between stars, an object that shouldn't behave the way it's behaving. And the more data we collect, the stranger it gets. Let me tell you what's happening right now, because what unfolded in the last few days has changed everything we thought we understood about this visitor. As 3E Atlas approached Perihelion, its closest encounter with our Sun, something extraordinary occurred. The comet's brightness didn't just increase gradually as expected, it exploded. The brightness surged at twice the rate it had been increasing before, twice as fast. Astronomers Chi-Chang Zhang from Lowell Observatory and Carl Battams from the U.S. Naval Research Laboratory documented this phenomenon in real time, and they had no immediate explanation for what they were witnessing. Think about that for a moment. This object has been traveling through interstellar space for what could be billions of years. It has passed through environments we can barely imagine. And now, as it gets close to our Sun, it suddenly becomes dramatically more active than any model predicted. Why? The spectrum analysis revealed something fascinating. The comet's light became bluer than the Sun's own spectrum. This blue shift indicates the presence of carbon molecules, specifically C2 and amidogen compounds, NH2. These are signatures of active ice sublimation. But here's what makes this unsettling. Radio observations detected that in just 2 weeks before perihelion, 3E Atlas was losing approximately 5.7 times 10 to the 28th power water molecules per second. That's 40 times more than it was losing just 1 month earlier. 40 times more water pouring out into space, like, as one scientist described it, a fire hose on full blast. Now, you might think this is normal comet behavior. Comets heat up near the Sun, ice turns to gas, they get brighter, standard physics. Except 3E Atlas isn't following standard physics. The rate of change is wrong, the timing is wrong, and what we're seeing doesn't match what we know about comets from our own solar system. Here's where it gets interesting. Space-based telescopes, SOHO, Stereo A, and the new GEOS-19 satellite, all equipped with coronagraphs that can observe objects close to the Sun, captured images of 3E Atlas during this critical period, and what they saw was unusual. The comet appeared as a faint but noticeably elongated spot. But here's what's strange. It had no visible dust tail. None. Just this stretched-out glow without the characteristic dust trail that comets normally produce. What does that mean? Well, some scientists have proposed that initially, carbon dioxide gas was escaping from the comet at a distance of about 3 astronomical units. This carbon dioxide would have been cooling the surface of the nucleus, essentially acting as a protective layer that prevented water from sublimating. But then something changed. That protective layer depleted, and when it did, the water ice underneath was suddenly exposed to direct solar radiation. The result? An explosive increase in brightness and activity. But there's another possibility, and this is where things get uncomfortable for some researchers. The composition of 3E Atlas's nucleus might be fundamentally different from anything we've seen before. Remember, this object didn't form in our solar system. It formed around a different star in a different stellar environment with different chemical conditions. What if its internal structure is nothing like the comets we're familiar with? What if there's something in that nucleus that we don't understand yet? The James Webb Space Telescope has been observing 3I Atlas, and what it found adds another layer to this mystery. Webb's near-infrared spectrograph revealed that this comet has been transformed by billions of years of cosmic ray bombardment. We're talking about galactic cosmic rays, high-energy particles that permeate interstellar space, striking the comet's surface continuously for eons.
According to research led by Roma Maggiolo from the Royal Belgian Institute for Space Aeronomy, these cosmic rays have fundamentally altered the physical and chemical structure of 3I Atlas. Computer simulations suggest that cosmic rays have penetrated approximately 50 to 65 feet deep into the comet's surface, creating what scientists are calling a deep irradiated crust. This crust no longer resembles the pristine material from the comet's home star system. It's been cooked by radiation for so long that it's become something else entirely. Here's the paradigm shift. Scientists have been hoping that interstellar objects like 3I Atlas would give us a window into other stellar systems, that we could analyze these visitors and learn what conditions are like around distant stars. But if Maggiolo is right, what we're looking at isn't a pristine sample from another star system. It's a heavily modified, radiation-processed shell that has been fundamentally changed by its journey through interstellar space. Maggiolo said something that should make us all pause. He said that 3I Atlas is now a product of its interstellar journey rather than where it came from, at least on the outside. Which raises an obvious question. What's underneath that irradiated crust? What's hidden in the core of this object that might still be pristine material from its origin system? And here's something most people don't know. Professor Avi Loeb, the former chair of Harvard's astronomy department, has formally requested that NASA release all scientific data on 3I Atlas to the public. Why would he do that? What does he think might be in that data that NASA hasn't shared yet? The behavior of 3I Atlas after perihelion is now the focus of intense scrutiny. Scientists admit they don't know what will happen next. Will the brightness continue to increase? Will it suddenly fade? Zhang and Badams noted in their observations that the comet's evolution after perihelion could be just as unusual as the outburst that preceded it, maybe more unusual. And that uncertainty is what makes this moment so critical. We're watching in real time as an object from beyond our solar system does something we can't fully explain. At perihelion, 3I Atlas reached a visual magnitude of approximately 9. That's bright enough to be visible through small amateur telescopes if you knew exactly where to look. But here's the thing. It was positioned so close to the sun in our sky that observing it from Earth's surface was nearly impossible during that crucial moment. We had to rely on space-based coronagraphs to see what was happening. And what they showed us was an object that looked nothing like a typical comet. The images revealed this elongated, glowing form without the expected dust tail. Instead, what we're seeing appears to be primarily gas emission. The hydroxyl glow, the signature of water vapor escaping from the comet, was detected by NASA's Swift ultraviolet echo-optical telescope. But the lack of visible dust, that's anomalous. Comets produce dust. It's what makes their tails so spectacular. So where's the dust from 3I Atlas? One possibility is that the composition is fundamentally ice-rich, with very little solid material to produce dust. But that doesn't fully explain the explosive brightening. Another possibility, and this is where some researchers get uncomfortable, is that the object's internal structure is unlike anything we've classified before. Now let's talk about what the James Webb Space Telescope revealed, because this is where the story takes a turn into territory that challenges our assumptions about interstellar objects. Webb observed 3I Atlas back in August, before the perihelion passage. The near-infrared spectrograph instrument analyzed the light coming from the comet, looking at the specific wavelengths that tell us what molecules are present. The data confirmed something that earlier observations had hinted at. This comet is rich in carbon dioxide, unusually rich. But more importantly, Webb's analysis revealed that the outer layers of this object have been fundamentally transformed by cosmic radiation. Here's what that means. In our solar system, we have a protective bubble called the heliosphere, created by the solar wind streaming out from our sun. This heliosphere shields us from most galactic cosmic rays, those high-energy particles that come from supernova explosions and other violent events across the galaxy. But in interstellar space, there is no such protection. Objects drifting between the stars are exposed to the full intensity of cosmic ray bombardment for millions or billions of years.